All right, we're going to do a quick review on the equations of lines, and hopefully the first thing you think of when you think of lines is the slope of the line. Right, the slope is an indication of the steepness of the line, and so here's a line that I've drawn in the plane, and if we have 2 points on the line, I'm going to draw 2 points, point number 1 maybe, and the way we'll designate point number 1 is by using the coordinates x subscript 1, y subscript 1, right, to indicate this is the x and y coordinates for point 1. And then let's pick another point on here, point 2, and we'll use x sub 2, y sub 2 as its coordinates, so point 2. So then the slope, which sometimes, right, is given the letter m to indicate the slope of the line, is equal to, well, a lot of things here, right? The vertical change divided by the horizontal change. Okay, so what is that? What does that mean? As we move from one point to another, what is the vertical change? What is the vertical change? Well, if I think about moving from this point to this point, I can move along this line, or I can think about going up some vertical distance until I reach a height that's equal, right, basically the y2 height, right, and then moving over horizontally to that point, right? And so this right here would be our vertical change, right, our vertical change. And basically I can find the vertical change by what? The difference between the y coordinates, y sub 2 minus y sub 1, right? That's what we've written here. And then divided by the horizontal change, right? The horizontal change is as we move horizontally from point 1 to point 2. So here is the horizontal change, and that is going to be what? Just the difference of the x coordinates, x2 minus x1. All right. This is the change in y over the change in x. Sometimes you've maybe seen this little triangle, or there's a Greek letter capital delta, delta y over delta x, change in y over delta x, or you've probably heard rise over run. I've got rise in quotes because the line could also be falling. But it's the directed vertical change over the directed horizontal change. So the slope is a measure of that magnitude. And so this should be familiar to you. With that, we can talk about classifying lines in one of 4 ways. We can have lines that are increasing as we move from left to right. And they're going to have a positive slope because the vertical change as I move from left to right is positive, right? And the horizontal change is positive as I move from one point to another going left to right. If I go from right to left, I can do that as well. Then my vertical change is negative, but my horizontal change is also negative, and a negative divided by a negative is still positive. So there's our positive slope when we're increasing. If the line is decreasing, we're going to have a negative slope, because here if I move from left to right from one point to another, vertically I'm going down, right? So that's going to be a negative change, and then horizontally I'm positive. So a negative divided by a positive will give you a negative quantity, and so there's our negative slope for decreasing lines. If we have a horizontal line, then the slope is 0. We have 0 slope. Okay, we don't say we have no slope, we have 0 slope. And that's because the change in the change in y, the whole vertical change is 0, right? If I move from one point to another, moving left to right, the y coordinate remains the same. So that y2 minus y1 difference here would be 0. Divided by any change in x will be equal to 0. There is essentially no steepness in this line if the slope is 0. Then a vertical line, and a vertical line here, notice the horizontal change is 0. As I move from one point to another, the change in x is 0. And that results in what? Division by 0, right? The change in x being 0. And of course, division by 0 is not defined. And in that case, we get an undefined slope. Don't use the term no slope. It's either slope of 0 if you have a horizontal line, or the slope is undefined if you have a vertical line. Now, from this idea of the slope, we can get our so-called point slope form of the equation of a line. If we know the slope m and a given point on the line, then we can find the equation. If x comma y is an arbitrary point on the line, so by arbitrary, notice this is a given point. I've got subscripts on x and y to indicate that it's going to be a given point, so we would know the coordinates of this point. But here, x, y could be any point. Right? As we move along that line, different points will have different x and y coordinates. So this is arbitrary, and we want an equation relating these two variables together. So what would the slope of this line be? The slope of this line would be the change in y. What's the change in y here? If I go y1 minus y is one way I can express that change, over x1 minus x. Or I can do it the other way. Notice I can do y minus y1 over x minus x1. The important thing is that if we subtract the arbitrary point from our point 1, right, we've got to do the same direction in the numerator and denominator. If I subtract our arbitrary point minus this point 1, then we again have the same direction of subtraction here. So I'm going to use this actually here, that m is equal to this expression, to get our point slope form of the line. And what I'm going to do is I'm simply going to multiply both sides of the equation by the denominator here, x minus x1. So again, if I multiply both sides, then what am I going to be left with over here, right? The x minus x1 will cancel here, and I'll just left the y minus y1. And this is our point slope form. Sometimes we write the y minus y1 on the left-hand side. It really doesn't matter. This is the way you'll typically see the point slope form of an equation. Okay, but it comes directly from the definition of the slope of a line. So you should be familiar with the point slope form. So if you know a point on the line and its slope, you can write the equation of that line. And so let's use what we've just done to find the equation of a line passing through the point 5 comma negative 4 with a slope of negative 3, right? So the slope is negative 3, and this is our given point, so that will be my x1 is 5 and my y1 is negative 4. So what's the equation going to be? Y minus y1, which is negative 4, equals m, which is negative 3, x minus x1, which is 5. And there's the equation in point slope form. There's the equation in point slope form. Now, what we typically like to do with that is to solve this equation for y. And it's easier anytime we have y as a function of x, when we can plug in different values of x, we can plot points, we can sort of see the behavior of that particular function. So let's do that. Of course, this becomes y plus 4 here. And if I distribute this negative 3, what do I get here? I get negative 3x. Be careful here. Negative times negative, positive. 3 times 5, 15. And then solve for y, I subtract 4 from both sides. 15 minus 4 is 11. So there's the equation of the line. Now this equation is not in point slope form, we say, but it is in what we call slope-intercept form. Slope-intercept form. And you'll notice right here that negative 3 is the slope, right, of the line, right? And that's the coefficient in front of x. And that's important, right, because the slope tells us, right, for every change in x, it's going to multiply by negative 3 to get the resulting change in y. So that makes sense that we're multiplying the slope by the x coordinate. What's this 11? Well, if I let x be 0, what am I talking about? I'm talking about the point that's on what? The y-axis. When x is 0, I get y is what? 11. So 11 is indeed the y-intercept for the line. And so that gives us the familiar slope-intercept form of an equation. Okay. So we have two forms that we can work with for the equation of line, the point-slope form that we just gave, and this slope-intercept form. Let's see how both of them work in this example. Find the equation of a line passing through the points negative 1, 5 and negative 3, negative 4. Okay. So to do this, it is helpful to sketch, I think sometimes, the line first off, just so you have a reasonable expectation for what you should get for the equation, in particular the slope. So let's plot this point. -1, comma 5 is going to be right here, and -3, comma -4 right about here. And so I can draw this line. Right. And certainly we see this line is increasing, and so what do we know about the slope? It should be positive. Okay, and that's important. It's typical that we sometimes make little mistakes subtracting, and so we need to be careful and have ways of determining, is our result reasonable? So this helps us take a look at it. So let's check out the slope. It's the change in y, right? So I'm going to do the y coordinate of this point minus the y coordinate of this point. So I'm going to do -4 minus 5. That means I have to do what? -3 minus a -1. Okay? If you don't subtract the same direction in the numerator and denominator, right, you're going to get opposite sign for the slope. Okay? If I know what the slope is in terms of sign, that it's positive here, that will help me not make that mistake, hopefully. -4 minus 5 is -9. -3 minus -1, -3 plus 1 is -2. Negative divided by negative is indeed positive, and so I get +9/2 as my slope. And that's good, because I have a line with that is increasing, so I know its slope should be positive. So basically this means what? I'm going up 9 units. For every 9 units I go up, I go over 2. So let's use the point slope form, okay? And in the point slope form, if you remember, let's rewrite that here. What do I need? I need a point and the slope. Well, I have a slope. Do I have a point? Well, yeah, I have 2 points. Well, which one do we use then? It doesn't matter. Either point. I can use either point and I'll get the same equation. Okay, so I want this point here. Let's use the point -1 comma 5. So this is going to be my x1 and this is going to be my y1. My slope m is 9/2. So I've got y minus y1, which is 5, equals m, which is 9/2, x minus x1, which is -1. Of course, this becomes in here x plus 1, right? And then I could solve for y like I did before. Let's do that. Distribute the 9/2. 9/2 times x is 9/2 x, and 9/2 times 1 is 9/2. And then I need to add 5 to both sides. And when I add 5 to 9/2, how do I do that? Well, 5 is equal to 10/2, right? 10/2. And so 9/2 plus 10/2 is 19/2. And there's the equation of the line in slope-intercept form. Now, I could also start with the slope-intercept form of the line. Let's see how that would work. Y equals mx plus b. That is supposed to be useful if you know the slope and the y-intercept. And I don't know what the y-intercept is. I do now that over here. But if I hadn't done this, how would I know what b was? Well, here's the thing. X and y have to satisfy this equation. Any point on the line should satisfy this equation, any xy point. And I have 2 of them. So I can plug in again one of these 2 points for x and y. I know what m is. That means I can solve for b. All right, so m is 5. Y is 5. M is what? 9/2. And x is what? -1. Right? And now I can solve for b. Right? I get -9/2, right? Plus b is 5. So what is b? I add 9/2 to both sides. I get 5 plus 9/2. Well, that sounds familiar. 5 is 10/2. Plus 9/2 is 19/2. And from that, I can go right to now saying what? Y is what? M is what? 9/2 x plus what? B, which is 19/2. And I get right to this as well. So you can use either the point slope form or the slope-intercept form if you're given 2 points on the line. Okay. Another thing you might want to do is just, once you have your formula, is indeed to check that not only this point satisfies your equation. That means when you plug in x is -1, you get y is 5. But also when you plug in this point, so when x is -3, if you replace x with -3 here, your result should equal -4. Okay, and I would encourage you to do that as a check. So it's always good to check your work and see that it's reasonable. Okay, let's just make sure we can sketch lines, right? So sketch the line whose equation is this, y equals 3x minus 2, where we know from the slope-intercept form that my slope m is 3, and here my y-intercept is negative 2, or as I like to write, 0, comma, negative 2. But the y-intercept is negative 2. So how do I sketch the line? I go to the y-intercept, which is 0, comma, negative 2. And then how do I plot another point on the line? Well, the slope is 3, and 3 is the same as 3 divided by 1, which means in going to the next point, vertical change of 3, I go up 1, 2, 3. Horizontal change of 1, I go over 1. Alternatively, it's also equal to negative 3 divided by negative 1, right? That's still positive 3. And going that way, I can go what? Down 1, 2, 3, and to the left 1. That's going in the negative direction, right? And I can continue to plot points. I really only need 2, but if I plot a few, then I can sketch that line. Here's the line, y equals 3x minus 2. We can also go in the reverse. Find the equation of the line whose graph is given and write it in slope-intercept form. Okay, well, we know what is the y-intercept by looking at this graph. 1, right? Or what I like to write, 0, comma 1, right? When x is 0, y is 1. We know that. What's the slope? What's the slope m? Well, as I go from one point to another, where do we go? Well, let's find another point on the line. There's lots of points I can choose from, but the one I'm going to choose is this one right here, maybe. That right is in the crosshairs, so to speak, right? So I can clearly see that x is 2, y is negative 2. So what is the slope? I go vertically, I go what? Down 1, 2, 3. Vertically, negative 3. And horizontally, I go 1, 2. Right? So the slope is negative 3/2. And so I'm ready to write out the equation in slope-intercept form, right? Y equals mx plus b. And so I get y is negative 3/2 x plus 1. A couple other things to remind us about lines. Horizontal lines, we talked about those being lines that have a slope of m equals 0. So what is the equation of any horizontal line? Well, if I plug it in the slope-intercept form, if y equals mx plus b, m is 0, 0 times x is 0, I just get y equals b. So the slope of any horizontal line, right, is going to be y equal b. So horizontal lines, y equal a constant. And of course that constant is indeed the y-intercept. Vertical lines, right, have a slope that's undefined. What's the equation of any vertical line then? Well, if it's going to have an x-intercept of a comma 0, right, then the equation of the line is x equal a. So vertical lines, right, x equal a. So notice when I say y equals b, that means x can be anything. Right? Horizontally, x can be anything. Vertical lines, x is a fixed value and y can be anything. So let's find the equation of horizontal line, the horizontal line passing through the point 5 comma negative 2, and sketch the line. Well, we can sketch the line pretty easily. 5 comma negative 2 is here, and what's our horizontal line, right? It's going to be this line right here. And remember, horizontal lines are always what? Y equal constant. And what's that constant in this case? Negative 2. That's the y-intercept. So notice any point on this line, what's the y-coordinate? Negative 2. What's the x-coordinate? Well, it could be anything, right? We got 4 comma negative 2, 2 comma negative 2, 0 comma negative 2, and so on. Find the equation of the vertical line passing through the point 5 comma negative 2. Well, that's easy too. I plot that point 5 comma negative 2. We draw that vertical line. And what's the equation of this line? Vertical line, x equal what? 5. Right? That's the x-intercept, right? Notice we're at 5 comma 0. So any point on this line has an x-coordinate of 5. The y-coordinate can be anything. So it could be 5 comma 0, 5 comma negative 1, 5 comma negative 3, and so on. Notice vertical lines are the one exception in terms of we can't write them in slope-intercept form because the slope is undefined. And notice for functions, linear functions, vertical lines, y is not clearly a function of x. So any other line, horizontal, increasing, decreasing, we can write y as a function of x, but not vertical lines. Two last things to remind you about. Two lines are parallel if they have the same slope but different y-intercepts. Two vertical lines are parallel, therefore, if they have different x-intercepts, okay, since their slopes are undefined. Two lines are coinciding if they have the same slope and the same y-intercept. And two lines intersect if they have slopes that are not equal. So let's find the equation of the line parallel to this line that passes through this point. Okay? Well, if we're parallel to this line here, then the slope of our line is the same as the slope of this line. What is the slope of this line? 4 times x. Is it 4? Well, no, this is not in slope-intercept form. I can't tell what the slope is until I put it in slope-intercept form. How do I do that? I have to solve for y. How do I solve for y? I'm going to subtract 4x and add 3 to both sides. And then what? Divide by 2. Divide everything by 2. Negative 4 divided by 2 is negative 2x. 3 divided by 2 is 3/2. There's the equation of this line, not the line that we're trying to find the equation of. Our line is parallel to this line, so what do we know? Well, the slope of this line is negative 2, so the slope of the parallel line is the same. Okay? So our slope of our line is negative 2. We are passing through this point, though, and so what do we have? Let's do point slope form. Right? So our point x1, y1, our slope m is negative 2, so y minus 1, y1, equals slope negative 2, x minus 2. Right? So there's our x1, and there's our y1. And there's the equation. I can solve for y now and put it in slope-intercept form. Distribute the negative 2. I get negative 2x, negative times negative, positive 4. Add 1 to both sides. I get negative 2x plus 5. Notice the equation of this line is not the same as the equation of the other line. These are parallel, right? They have the same slopes but different y-intercepts. But this is the equation of the line we are interested in. So parallel lines. Now, if lines are intersecting, there are a special case of intersecting, right, you should be familiar with, and that is two lines being perpendicular if their slopes have a product of negative 1. So if we have two lines, lines 1 and line 2, and we multiply their slopes, it's equal to negative 1. Another way of thinking about this, if I solve, for instance, for m1 by dividing by m2, I get this relationship, which basically says that the slopes of lines are opposite or negative reciprocals of each other's. Okay, so the slopes of non-vertical perpendicular lines are negative reciprocals of each other. So if the slope of the line is 2, a perpendicular line would have slope of what? Negative 1/2. If the slope of the line was 2/3, then the slope of the perpendicular line would be negative 3/2. And so on. A horizontal line of slope 0 is perpendicular to any vertical line where the slope is undefined. Okay. Of course, what do we know geometry-wise, geometrically is what I'm trying to say, for perpendicular lines? They intersect at what? Right angles, or 90 degrees, right? So we're talking about perpendicular lines, then they intersect at 90 degrees. Okay, so let's find the equation of the line that's perpendicular to the line 4x minus 3y equals 0 and passing through this point. So again, what is the slope of this line? We need to know what that is. I'm going to solve for y. So I have what? 4x equals 3y if I add 3y to both sides, and then divide by 3, I get y is equal to 4/3 x. And so the slope here of this line is 4/3. Okay? But what is the slope of this line that's perpendicular? So the desired line, we'll say, has slope, what? Equal to what? The negative reciprocal. So negative what? Reciprocal of 4/3 is 3/4. That's the slope of our line that we're looking for. We pass through this point. Let's let that be x1 and let that be y1. And so our equation from our point slope form, y minus y1 equals m, which is now negative 3/4, x minus a negative 3, which becomes x plus 3. X minus a negative 3 becomes x plus 3. So there's our equation. Again, we'll go ahead and finish it off by putting it in slope-intercept form, distributing. I get negative 3/4 x minus 9/4, and then I need to add 5 to both sides. And adding 5 is the same as what? Adding 20/4. 5 is 20/4. Negative 9 plus 20 is positive 11/4. Okay. Now my math sometimes, my arithmetic is off sometimes. I make little mistakes, so it's always helpful to check, right? Go back and make sure, first of all, we pass through this line. Do we indeed pass through this line? When x is equal to negative 3, what do we get for y? Well, I get negative 3 times negative 3 is positive 9/4, so this is 9/4 plus 11/4, which is 20/4, which is 5. Is that what we're supposed to get when x is negative 3? Yeah, so that's good. At least our point is on the line. And double check and make sure we see that the slope of this line again was indeed 4/3, and the slope of this line is negative 3/4. When you multiply negative 3/4 times 4/3, you get negative 1, which means the lines are indeed perpendicular. Okay, so that's a fast review of lines and linear equations. Hopefully this is familiar to you. We will be using this throughout this semester.